Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we want to talk about simple harmonic motion calculations. So let's just do a quick review. What is simple harmonic motion? You have this, some kind of a repeated process going back and forth and back and forth. Examples of this would include an oscillating pendulum, something going back and forth. The vibration of your eardrum follows simple harmonic motion. The motion of a spring, a swing in the park, or a spring mass situation. Take a look at some examples here. Even like you've got a bowl up here. In this bowl, if you have the ball rolling in some kind of like a metallic bowl, it's going to obey simple harmonic motion. If we look down here, here's that spring mass situation right here. Or here's an interesting one. If you just like take a clamp on a table and you push it down and boing, 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 simple harmonic motion. Or conversely, same thing if you take and you push it back and forth, as you can see in the image. So that's the gist of simple harmonic motion. It follows certain equations. I'm not going to take any time to derive them, but let's take a look, and it's important that you write down these key equations. So you can see in the upper left-hand corner, you've got, so first of all, let me back up. They follow a sinusoidal curve. You can see the curves. There are three sets of equations: position, velocity, acceleration. And you can see the three key equations. X is in, by the way, this could also be Y, or they're all written as X's, but they could be moving in the Y direction sometimes. A cos 2 pi at the frequency times the time. Now, note that T is time, big T is period. And then you can see the velocity equation and acceleration equation. And then over here, I'm kind of hiding behind this here. You can define how can you find the maximums of X max. Now, X max stands for A. That's what's called the amplitude. That's how tall the curve is. And then we can find the V max and then the A max, and you can see the equations. So those are all the equations. Let's do a sample problem. Let's now do a sample. Let's now do a sample problem. A classic children's toy consists of a wooden animal suspended from a spring. If you lift up the toy by 10 centimeters, let it go, it will gently bob up and down. So we've got a here, and then we've got a spring, and we've got the toy. I'll just write toy. Right, and then when you pull this down, and you pull it down by, lift the toy up, I guess you lift it up by 10 centimeters, it bobs up and down. So it has an amplitude. This will be 10 centimeters, and then it will probably oscillate another 10 centimeters down. And we want to figure out a number of things. You got like an A, a B, and a C. So letter A says, what is the frequency? Now remember, frequency, that's not in the equations on the previous thing. Frequency is measured in hertz. So frequency is in units of 1 over seconds, or seconds to the minus 1. Same thing, right? And so if I want to do this, what I would do is I know how many oscillations happen in a second. So I can say 4 oscillations in 10 seconds. So the oscillations isn't really a unit, but it's convenient to write it this way. And the 4 over 10, I can do it in my head. That's 0.4 seconds to the minus 1, or 0.4 over seconds. And that's equal to 0.4. And the units we use to actually say that is hertz. So that's the answer to A. To B now, what have I got on B? B says, when does the toy first reach its maximum speed, and what is this speed? What is the speed? So maximum speed, we're going to use the equation, the V max equation that we see here. So V max, I'll write it on the board. You can't see me doing this because I don't remember it. V max equals 2 pi FA. So here I've written it right here, 2 pi FA. And so I'm just going to plug this in. What's the maximum speed? So it'll be 2 times pi times my frequency, 0.4. Now, what is the amplitude? So the amplitude here is 10 centimeters. but I'm going to put that in meters, or 0.1 meters, right? 0.1. So simply the max speed, what have I got here? Max speed is 0.25 meters per second. I just multiply it out. Super easy, right? And what are the position and velocities? Actually, part C has 2 questions. After 4 seconds. All right, so for part C, you've almost got like a C and a D, right? So the first thing I did after 4 seconds, I want to use now the equation. Let's flick back to the screen here before. I'm going to use the position equation right here. So that's going to be x equals a cos of 2 pi ft. Okay? So x is a cos 2 pi ft. So a is the amplitude, so that's 0.1 times the cosine of 2 pi ft. So 2 pi, f was times 0.4 times, times 4 seconds, right? And note, I struggled with this. I couldn't get the right answer. My issue was I didn't have my calculator in radians. So it's very important that you get your calculator in radians. This is all a radians when you talk about cosine's equation. And so I got x equal to negative 0.81 meters. So I was looking at this and I thought, wait a second, that can't be negative 0.81 because the amplitude is 0.1. So I put it back into my calculator and this is wrong, negative 0.081 meters. Because it's going to range between negative 0.1 and positive 0.81. Anyways, so watch that. So as you're doing problems like this, always ask that question, does that number seem reasonable? It was not reasonable. So yeah, boom. Now, the next question is I think it's an interesting question. What is the position and the velocity after 4 seconds? Now, to find the velocity, we'll flick back to our equations. We're going to use this second equation here, the velocity, Vx of t is negative Vmax, etc. So I'll recopy the equation maybe over here. I'm going to say V of t is equal to negative Vmax times the cosine of 2 pi ft. Now, in this case, we are solving for the velocity, so we're just going to plug in everything we have here. And so what have I got? The Vmax is 0.25, so this is equal to negative 0.25 times the cosine of 2 pi times 0.4 times 4. And what I get there is I get V equal to 0.15 meters per second. Now that does seem to make sense. If you recall, the max speed was 0.25. This speed would be 0.15. That seems like a reasonable number to me as I'm solving the problem. Now, when you're doing problems like this, whether they're in class or whether they are, through the mastering program, what you may realize is that sometimes you're going to know the velocity here and you'll find the Vmax, etc. Another thing I would recommend as you're doing these problems, so often 2 pi f, let me actually make a note here, 2 pi f is rho. That's a W, if you make sense. It's the rho letter. This is the angular speed. And so sometimes it's because you'll see 2 pi f lots of times. And sometimes if you calculate this and if you're doing repetitive calculations, you may just want to find what is 2 pi f. And then it will save you having to just type it out many, many times on the calculator. So I sometimes find that's really useful when you're doing these calculations. Hey, Houston, we don't have a problem. We'll see you in class.